Welcome to my podcast, Jack to the Future. From science and inventions to pollution and recycling, I talk about what's changing in the world, the future, and how we can help with that. Every month I'll talk about a different future theme. For example, the future of science, tech, sustainability, reading, music, and all sorts of other ones. The future of everything. Did you know? You can find me on Facebook and Instagram as Jake to the Future and on YouTube as Jack to the Future. Follow me to get behind the scenes info, access to the previews about my next episodes, and much, much more. This week's episode is about the future of computers. There is so much to think about and I couldn't possibly do it all. Today, I'll be talking about data storage and cloud computing. I talked to a cloud architect engineer who works for Microsoft about what her job involves and what the cloud actually is. We talk about keeping your information safe, what data storage may look like in the future, and some very cool and different ways that it can be stored. Right before we get started, there's a few things I need to explain. First of all, what is data? Data basically is information which could be pictures, videos, audio files, that kind of thing. That information is changed into a different form that makes it easier to move it or handle it. Usually nowadays that is a digital form because that can be used on a computer. Data is stored in binary numbers. You may have heard of that. Basically it's ones and zeros.
0, 1, 1, 0, 1, 1, 1, 1. Binary code.
The amount of data or information stored is measured in bytes. The prefix name for a byte of data changes as it gets bigger and bigger. So it starts with a byte, then it goes to a megabyte, then a gigabyte, and then terabyte, and then a petabyte, and then exabyte, and then zettabyte. A zettabyte is 1 trillion gigabytes. That's a lot. Like a lot. Together, we generate 2.5 exabytes of online data every day on the internet. With things going the way they are, by 2025 we'll be storing 160,000 exabytes of data per year. That's amazing. Some number facts for you here. There is more bytes than there are stars that we can see in the universe. Mind blown. Some people think that 5 exabytes is the same number as all the words ever spoken by a human. That is incredible. All the words, even includes my words that I'm talking right now. To have recorded 1 exabyte of data, you would have had to start a video call 237,823 years ago. Wow. That is a really long time ago. An office full of 100 people would need to search the internet for 57,077 years to use 1 exabyte of data. That is a lot. Everyone has data, and there are about 3.7 billion people using the internet right now. More and more people want to store their data on the internet now and in the cloud for several reasons. If you listen to this podcast, you'll find out some of them. So what is the cloud? Here's the audio from a video that my special guest recommended. Mum will put the YouTube link in the description if you'd like to see the visuals too.
So imagine you have a dog, and your dog's name is Frank. It's a strange dog name, but just go with it. You and Frank are best pals. You go on walks together, Frank always walks faster, but still, you really love Frank a lot. You only have one photo of Frank though, the Scoofy shot of Frank at his birthday party, drooling on the cake. And because you love this weirdly named dog so much, you're worried you might lose this photo. So you upload the photo, your favorite photo, to one of your favorite photo websites, like Flickr, Facebook, or Picasa. And without realizing it, you just started cloud computing. But what does that mean? When you put Frank's photo online, you could picture a giant cloud coming down to vacuum up this photo off your laptop. Then the photo of Frank, birthday hat and all, lives up in the cloud until you need to look at it again. You log onto Flickr or Facebook, and there's Frank. You can see him from wherever you want, from home, from work, even on your phone, in case you start missing Frank during your lunch break. At first, the cloud seems like magic, but it's not. It's hard to know exactly where your photo of Frank may be once it's in the cloud. Frank may be chilling in Paris or hanging out in India. There's really no way to know for sure. You just have to trust a web company, like Google or Microsoft, to keep Frank safe. There are a bunch of reasons to do this. The first is that, well, you only have one photo of Frank. It's on your laptop, and if that laptop breaks, if an alien comes to steal the data, or if your apartment melts when a volcano erupts, you're out of luck. No more Frank, no more memories. But when Frank's in the cloud, he's stored not just in one place, but all over the place. so you're less likely to lose him. You also can access Frank's photo from anywhere. You can send a link to some of your friends so they can see Frank too. That's just one of the many powers of cloud computing. And it's not just you and Frank. Entire businesses are running in the cloud. There are plenty of reasons to be scared of the cloud too. But for now, you decide to trust the cloud as backup. If Frank's happy, then you're happy.
So how do we get information from the cloud? Excuse me, cloud? Please can I see my photo again? Nope, that's not how it works. Many people don't realise that despite being held in the cloud, data still needs to be physically stored somewhere. At the moment, there are data centres all over the world that looks a bit futuristic, building with racks and racks of servers storing our data. You can think of a server like a supercomputer. It processes, requests and delivers data to another computer over the internet or a local network, so connected computers in one place. I will post a picture on social media. But what reminds me of a supercomputer is quantum computers, but we won't go on to that because that's really complicated. Did you know that a single data centre uses more electricity than a small town? We can't carry on like this in the future. We don't have the space, and we can't be generating so much carbon dioxide just to be able to save that picture of your favourite giraffe that you saw at the zoo. So, where are we going to put it all, and how can we reduce the amount of energy that we use? I guess we could just delete some of the data, but that would be down to every person to take responsibility, so I think we need to find better ways to store data. Dulcie and I will talk about this a bit later on. Do you have any ideas about a solution to data storage in the future? Today I'm joined by my special guest Dulcie Herreros, who is a chartered engineer and works for Microsoft as a cloud solution architect. I'm going to be talking to her about the future of computing and more specifically storing data in the cloud. Thanks for being here, Dulcie.
Hello, thank you for having me.
Hello. There's lots of big words to understand in the area your isn't there.
I think adults get so wrapped up in the business world that they stop being able to communicate things in an easy way, right? I even get it all the time at work. I'll have people, instead of just using words, they'll just use letters. And I'll be like, what does that mean? Can you explain it?
What do you mean by letters?
Yes.
Acronyms.
Yeah. So I'll do my best not to. I know that cloud is quite a complicated subject.
Like, because if you just say, for example, TAD, you'll be like, what's that stand for? It could be for training alternative dogs.
So I mean that, like one example is when people say GCP instead of Google Cloud Platform. So that's one that we hear in business, but there are loads and loads, and sometimes people just make up their own thing, right? So it gets confusing because you have letters for loads of different things that mean you have to stay switched on.
So what is the cloud? Is it just where you can store your information and photos on the internet? And why do we need it?
So the easiest way to describe the cloud is as a rental service. Imagine you might own your own computer or laptop. Large companies need lots of computers and other hardware so that the people that work there, their employees, can access the internet and use bits of software and things like that. So as you can imagine, this is really expensive for businesses, especially since technology evolves really quickly and they need to constantly update the hardware that they have. When I was growing up, computers were sort of really bulky and extremely slow. So you would have probably never seen anything like this, Jack. But
yeah, they're like
old.
They're fat.
Precisely, really old computers. And, my first basic computers struggle to run a game or different workloads at the same time. I've upgraded my computer lots and lots of times so that I can work more efficiently, so that I can do things more quickly. I don't have to wait for things to load up. And personally, it's cost me quite a bit of money to do that. A good computer can be quite expensive. So thinking on the lines that hardware is expensive, what can organizations do to cut costs? Well, what they do is they sort of rent hardware from their cloud provider. So the most well-known cloud providers are Microsoft, Amazon, and Google. And these organizations have huge data centers around the world full of hardware. So imagine I work for a business and don't want to buy my own computer. What can I do? I can create something called a virtual machine, which has hardware running in one of those data centers belonging to a large organization. So next, imagine I start a complicated project and that virtual machine is slowing down. What can I do? I can easily resize that machine within the cloud without personally spending a penny. on hardware. It's as simple as clicking a button. So this can be really cost efficient for organizations. So probably for most individual users like you, they use cloud services, like you said, to back up photos on the internet. There are a couple of benefits to doing this. So firstly, if your personal phone or computer breaks, the images remain safely in the cloud. So cloud data centers replicate data across the world to make sure that if anything happens, the data in them can still be accessed. And the second benefit is that you don't need to buy a device to store these photos onto. So like an SD card or something like that, you can just upload it straight onto the cloud. It's more than just a photo repository though. There are hundreds of services which are available in the cloud, including things like database services, security systems, storage and file systems, machine learning services. You name it, it probably exists in the cloud. So in really simple terms, that's what the cloud is and what people use it for.
Yeah, that is a really good explanation for it. I just wanted to ask, what is probably one of the main things that people say the cloud actually does? So
the main thing that the cloud does is essentially store information. I would say probably one of the biggest cloud services is storage. You know, that's not just photos, that can be different types of data, different types of files. You've probably heard of and used SharePoint and things like that. So use it as a repository. I would say that most of the other services that exist within cloud, perhaps not quite as big a footprint, but you can honestly do all sorts of things. You can host applications like what you have on your phone, different security services run in the cloud. So you get sort of things like Azure Firewall, which you can set up virtually as well. I think probably, Jack, you would struggle to name a computing service that didn't exist within the cloud.
Yeah. Okay. So the most popular thing people use it for is a repository. That organizes your information.
Loads and loads of good stuff.
You have to think of quite a catchy name to do it.
It is, yeah. I mean, some of the services do have quite cool names. My personal favorite is Azure Sentinel, which is a security service. You can go away and Google what Sentinel means later. Perhaps you could name one of your robots after it.
Sentinel is something or someone that watches. So the name is very appropriate because it's a security system to keep an eye on your information in the cloud. My next question has actually quite a lot to do with names. Why is it called the cloud? Because I think I call it the box because it contains stuff.
That is a great idea. We do actually have a service called Azure Data Box. So there is something like that. And that's used to transfer large amounts of data to the cloud. But back to your question, though, why is the cloud called the cloud? I've done a bit of digging on this one, and there are actually a number of different theories. The first theory is that the name originates from the cloud symbol that was used in sort of early flowcharts and diagrams, which we used to symbolize internet services. And that was all the way back in the 1960s. But there are a couple of other theories. Some people say the first name came about in the 90s in the offices of Compaq, which is a tech company. Apparently, the employees there began to use it. And still others believe that the first time it was used was at a Google conference in 2006. So a few different theories. Nobody has actually pinned down definitively the origins of the word cloud. So it's not completely clear. You'll have to let me know if you uncover any other theories and which one you think is the best.
I think it's probably likely that, clouds are kind of huge, really, and they contain weather. You could say water droplets are like a little pixels or bits of technology or something like that. I think that's probably a reasonable one. But
no, I know what you mean. A cloud is sort of a vast entity, isn't it? It's got loads of little water droplets in it.
So
I think I prefer that idea. More exciting than thinking about somebody dreaming the term up in an office, isn't it? So yeah. That's a good one.
You're a cloud solution architect. Architects usually have ideas about making things and then building them. Is that what you do, but with computers?
Mm-hmm. Yeah, that's right. So when businesses come up with an idea or a vision of what they'd like to do in the cloud, I help them come up with a solution that fits the idea. So a cloud architecture is essentially a diagram with sort of boxes, arrows, and logos which correspond to different products like Sentinel, which I mentioned earlier. Some companies want something really simple. For example, a set of virtual machines. So these are just computers which run in the cloud. And other organizations require complex architectures, which include several different services. So, for example, databases, applications, security systems, policies, virtual networks, you name it, it exists. To use your example, a traditional architect thinks about a lot of things: space within a building, walls, ceilings, staircases, plumbing, electrics, etc. So you can probably think of plumbing in the cloud as the way it had its resources and networks wired together over a number of channels. So it defines the way the services are delivered to the user in a cloud computing model. So I suppose an architecture would look like a big picture of connected services. That's probably the simplest way to explain it.
Yeah, that makes sense. I understand that. I know you're telling me simple explanation because I'm a child, but when you actually get into real business, it's really complicated.
Yeah, I don't know. It's one of those things, isn't it, where you could end up overcomplicating it. I mean, when you think of it in a really simple level, it is just sort of a web of connected services hosted in a data center somewhere. I think sometimes people get bogged down with thinking it's really, really complicated and they'll never understand it. But if you just think of it as hardware that exists somewhere else in the world, it's a little bit more straightforward to understand what's happening.
I like the video you sent me to help explain what the cloud was. Did
funny. You? I'm glad you enjoyed it.
It's quite funny. Because I like how simple the explanation was. I like it how they used with pictures and dogs. It was quite cute, actually, yeah.
Pictures are always a good way to look at things. If you want to see something more complicated, I can send you one of our sample architectures and you can have a look just for fun, see how the diagrams fit together and things. I'm sure it'll be good bedtime reading for you, Jack.
So like a spider's web with all the little connections to different webs. Yeah. So do you draw the map sort of thing for your customers to show them what's inside it?
Yeah, so it does take a graphical form. They are essentially diagrams. For example, if you were deploying cloud from scratch, so if you're an organization that has nothing in the cloud yet, we've got what we call a reference architecture or an initial deployment that you can deploy straight from one of our websites, and it will set up some basic services within the cloud that most businesses need. I mean, if you already have stuff set up in the cloud, then it needs to be tailored to what you're trying to do. So just as a really simple example of that, think of the military. They have a big requirement for security because they've got secret data and things like that. So what they would do is look specifically at how they can make workloads and things more secure. And we'll build out those pictures or architectures and make sure that there are no weaknesses between the services that are shown in an interconnected way. Like you said, like a bit like a web, you've got all this stuff here. How do you create those boundaries in the correct way to secure them?
Yeah. What happens to my information if your data banks go wrong or if they're hacked?
Okay, so it depends. If a hacker gains access to your data, there are essentially three scenarios. In the first instance, your data is encrypted. And if that happens, then the hacker will control the storage account, but they won't actually be able to read your data because it's scrambled due to encryption. They've sort of controlled your access to that data, but they don't necessarily gain any secret information that might be contained within it.
The bunch of God bloody goo.
In the second scenario, you have data that's encrypted, and the hacker has access to something called a decryption key and can read all of your data. So this can sometimes happen, especially if a hacker works, for example, for the cloud computing company and has some sort of malicious intent. And that's obviously the worst case scenario. Yeah. There is another scenario. So that's that your data is just not encrypted, i.e. it's stored in what we call plain text. So that's just readable, legible text like you would find in storybooks, and the hacker can just read it. Of course, as you can imagine, the loss of data can have consequences. So even if the hacker can't read the data, in the world of cybersecurity, there are three considerations that we look at. The first is confidentiality or privacy of your data. The second is something called integrity, which is looking at whether the data that you have stored has been tampered with or whether it remains in its original state. And the third is availability. So looking at whether you can access and use your data. So let's take the example of a common ransomware attack where the hacker locks your data down and demands money for unlocking it again.
Yeah, I've heard about those.
So your data might be encrypted or private, but suppose that information is very important and you need to access it regularly. In that sort of situation, it's availability that becomes the problem. You can't access it. It's locked away. So there are a couple of things that you can do to protect your data from hackers. So the first one is to encrypt your data so that they can't read it. So essentially scramble it and make it illegible to them. And the second is to back it up. So if they steal it, you can still access a copy. So there are some of the basic principles that we'd consider when we do things like threat modeling in the world of cybersecurity.
So, even though you save your work to the cloud, you still need a backup just in case. So how would you back your data up? How do you do that on the cloud?
Here's the clever thing, right? So imagine you've got data stored within the cloud, okay? That cloud provider will then offer backup services. And there are a few different ways that they can do that. It's something that's really, really important to businesses. So it has to be thought through in quite a bit of detail to make sure that, for example, if data is lost, they can recover it within a reasonable time frame. There are a few different options for you in backing up your data. So the first one is to back up a copy in another rack within the same data center. So imagine you've got racks of servers, and you've got one copy of your data on one and another copy of your data on the rack next to it. That's one scenario, but there are also other scenarios. So if that data is really, really important and any sort of loss of it would be catastrophic, something like a fire could happen that would take out the data center. So some organizations need to consider these things. So what they'll do is they'll pay for their data to be replicated to either another data center within the same geographic sort of region. So Microsoft have data centers in London and Newport. So you could make a copy in one or the other and have the original in one or the other as well. Or you can replicate it even wider, so across geographic regions. And that obviously offers the best protection from things like natural disasters, so earthquakes, fires, you name it, somebody sort of it has probably happened. So there's sort of your options around data backup. And again, that's based in sort of hardware facilities that are owned by cloud providers. But obviously you can also back up data at home. Like you could print something off and that essentially is a hard backup copy. It doesn't all have to be in the cloud.
Yeah, that makes sense. Because if you work really hard on something or it's really private, you don't want to lose it. Over lockdown, I used Google Classroom and Google Documents a lot for my home learning. And it was good because I could share my work with my teacher and classmates. But that's one good thing about the cloud. But can the people that work for Google, whoever, see your data?
Well, so that depends on the service that you're using and what you're using it for and whereabouts in the world you live. Some free cloud services and repositories are shared or public and others are private. There are a couple of things to think about in terms of how your data will be used by cloud providers. The first is what we call privacy laws in your country. So for you, that will be the UK. For example, we have something called the General Data Protection Act, or GDPR, there's an acronym for you, which sets out guidance on how our personal data is used here in the UK. So companies here are required by law to conform to the conditions laid out within that regulation. The second thing to consider is the type of service that you're using and what we call the terms of service. Some organizations offer free services, but in exchange, they'll collect your data. So one example of this is Dropbox. I don't know if you've heard of it, but they let you use their storage service for free, but in exchange, they'll collect data relating to the way that you use their service. And obviously that data is valuable to them, and that's the trade-off to using it for free. So other services are completely private and can't be accessed by engineers who work for the cloud computing company. And this is actually a necessary requirement in some industries like defense, where secret data is held on cloud systems. Coming back to Google Classroom specifically, when you upload files to this service, your data is encrypted at rest. So it's scrambled at rest. It's not legible unless somebody has the key to decrypt it, i.e. make it readable, put it in plain text form. You know, it's obscured from others unless they hold that key, which means that even if someone was to look at your document, they wouldn't understand anything it contained unless they had that key.
Would it just look like a bunch of letters, or would it just look like in a different sort of language?
There are different different types of encryption, so it would depend. But I would say if you want an example of what some encryption sort of looks like, there's a font on Microsoft Word. I think it's called Weddings, and it just makes the text really legible. Like it will put it into things like triangles. The range, it goes from sort of really basic encryption to really quite complicated. And what you'll see on the page is normally not text. It's normally little symbols, but it can vary depending on which sort of encryption you use. So we've got encryption standard. The sort of most common of those is something called AES 256, but there are a whole bunch of others that you can look into if you find it interesting. The takeaway is it's really important to check the privacy terms of any service that you're signing up to, particularly if it contains data that is sensitive or personal or that you wouldn't want accessed by somebody else.
Yeah. I don't think I've seen anything like that. I like code breaking. Sometimes I play a game with my mum and dad where I have letters and symbols and they have to work out what the answer is.
Really early examples are things like, have you heard of the Enigma machine?
Yes.
That's quite famous from the war. So it's along those sort of lines. That's what it does. It sort of mixes things up or changes things so that you can't possibly understand it unless you have that decryption key. I mean, no matter how hard you try these days, because it's so advanced, and the algorithms behind it are so complicated, the human mind could probably never break it. We've got sort of quantum computing experiments going on far and wide, and as technology develops, they're able to break more encryption. With weaker encryption methods, that can happen, and there are predictions that certain encryption standards will be broken, for example, within 10 years, just because computing moves on so fast, which is why people are constantly thinking up these new types of encryption, which can last for longer and longer and longer and potentially can't be broken by things like quantum computing. It's really interesting. You should look into it. If you go away and look at things like the Enigma machine, it might make a bit more sense.
Yeah, I will. I'd like to do that.
So what I can do is after this, I can send you an example of what some encrypted text might look like. You might find it interesting.
Thank you. Mum said she'll have to take me to see the Enigma machine. I can't remember his name. It was like Alan Turing. Yeah, Alan Turing. That's the guy.
Yeah, he's quite famous. There's actually a film that's came out a few years ago about Alan Turing, and that sort of talks about the process he went through to crack the machine, and that's quite a good watch as well.
Yeah, I think it might have been a 15 age certificate, so I'll have to wait a bit to watch it. But I read a book about inventions all about it, and it's really interesting. By 2025, Cyberzone magazine predicts that we'll be using over 200 zettabytes of data, which is 21 zeros. Do you think we're going to run out of numbers?
That's a lot of zeros, isn't it? But do I think we're going to run out of numbers? No, because the science and technology behind our data centers and our storage solutions is forever changing to meet demand from our users. So we've got people constantly on the case looking at how to upgrade systems so that they can sort of handle more data. And we'll talk a bit more about that later. But there are a number of great new initiatives focused on data storage. So I don't know if you've seen it, but we're building a data center under the sea. I think you should also check out something called Project Silica, which is an innovative long-term storage solution.
Really cool.
Also bear in mind that not all data that is created is stored forever. So most data is actually deleted and destroyed within 10 years. It's actually quite rare for data to be archived or stored very long term because organizations have to pay for that storage. Okay, so unless something has what we call like a mandatory retention period, like health data, for example, people would normally delete that data within a few years so that they don't have to keep on paying for storage accounts in the cloud, because obviously that's quite expensive for them.
Okay, that makes sense. How much data does Microsoft store?
As for how much data do we store at Microsoft, I'm not sure, to be honest, but what I can say is that we have some of the world's largest data centers and that they can store a lot of data. So the exact amount is constantly shifting as our customers add and remove data from the cloud. So as you can imagine, at one point in time, we might have slightly more data than another point as things are deleted, especially from large organizations.
Every second, people would be adding and deleting information. Yeah. So every second it will get higher and maybe a bit lower or something.
Yeah, that's exactly it. Because the data that we store, the life cycle, we call it life cycle of that data, it's different for everybody. as people sort of put data into the cloud and take data back out, it's in a constant state of flux. So from second to second to second, there will be a different amount of data stored within our cloud data centers. But obviously, we work globally. So we have data centers across the entire world, which means that we've got loads and loads of data, pretty much. Just that loads and loads is sometimes a little bit more, a little bit less.
Yeah, I understand that. This kind of associates with the next question, which was, I read on their website called KidPid, engineers are working with computer scientists about ways to store data in DNA because it stores a lot of data in a small space. Did you know that you can store an exabyte of data by cubic milliliter and it can survive for up to 500 years?
That is a super interesting fact. And no, I didn't know that specifically until you just told me, actually.
That's like storing 11 million HD films on something the size of a poppy seed. If you imagine the seed was more of a cube shape. This may help in the future as we may not need as many big data centers, especially if we're going to be using more and more data. Do you know of any other research or projects that may change how data is stored in the future?
Yeah, so Microsoft have been doing a lot of DNA-based data storage research and also looking at using something called quartz glass, which has an almost indefinite length of time for storage. So the project behind this is one I actually mentioned earlier called Silica, and that uses ultra-fast laser optics to store data in quartz glass by using femtosecond lasers. So that sounds really complicated, but essentially one of the big problems at the moment is that things like disks, SSDs, DVDs, tapes, all degrade over about 10 plus years. So Project Silica has been set up to look at storing data in this quartz glass longer terms. As you mentioned earlier, the demand for long-term data storage in the cloud is reaching unprecedented levels and continues to grow into the zettabytes. Existing storage technologies don't provide a cost-effective way of storing that data long-term, which is why this new project, Glass or Silica, is so important to us. Another project that you might be interested in is the GitHub archive program. I'm not sure if you've heard of GitHub, but essentially the program's mission is to preserve open source software for future generations by storing code in an archive built to last 1,000 years in the Arctic. It's an interesting project, and you can follow the code on its journey to the Arctic on the GitHub blog page, which I can send to you if you're interested, Jack.
Yeah.
It's quite cool.
I'll check out the project you talked about, but what I would think is quite cool is if you get a block of ice and you put it in the Antarctic, for a long time, that will probably not melt.
No.
It might stay there for quite a long time. And I thought if you managed to get an ice cube, like a huge one, as like the size of this room or something like that, and manage to store data inside the ice cube and put the ice cube in the Antarctic, you could be storing data in the ice cube, which would be weird.
Yeah, I mean, data is being stored all over the place, but this is just really cool because what you can do is you can go onto the blog page and watch it as it sort of goes over to the Arctic. So what I'll do, I'll send you a link and you can follow the blog and you'll be able to see it sort of on its journey to being stored for 1,000 years. I mean, obviously you won't be here in 1,000 years, but you can watch the beginning of the journey.
If they make something like our DNA go for a very long time and we try to stay healthy and avoid getting hurt, then you may live for 1,000 years.
Well, that's true. You know, there are also projects set up for maintaining people in ice. So look up cryonics or cryogenics. That might be interesting to you as well. It's nothing to do with the cloud, but it's super interesting. I used to love looking at it when I was at school. So I recommend you take a look.
Yeah. So what are they storing the data in exactly? Not ice, I assume.
That is a really good question. The headline is preserving open source code for generations. And so what they want to do is archive software across multiple organizations and forms of storage to help long-term preservation. So they've got this thing called the Arctic Code Vault in a decommissioned coal mine deep beneath an Arctic mountain. And that's where they're housing all of the data. So it's quite cool, right?
Yeah, that's a very unexpected place to to store data in.
It is.
Yeah.
It is. Yeah, you wouldn't believe some of the initiatives that are around. I mean, that's cool. Obviously, the underwater data centers are really interesting as well. If you look at that, I think, where we're running out of space, you probably know from the housing blog that you did before, that space is being used up. So we're just looking at ways all the time of storing things like in space, in the Arctic, wherever really. So,
Because sometimes we might just run out of space. Because I think we should put some other towns and countries and maybe even continents on other planets if we find a way to live there. But I mean, that's what they're trying to do. You could store data on Mars, maybe. You could do that.
Yeah, I don't see why not. I mean, we've already got a load of stuff up in space anyway. So satellites are used a lot for communicating things back down. We've got even satellites that store image data. They'll take photos, take images from up in the sky and then send them back down to data centers on the ground. So we've already got things like that. So actually storing data in space wouldn't be too much of a massive jump. I think it's coming pretty soon.
Yeah. What if someone drops the glass? Well, is quartz much stronger?
I don't know how much you know about chemistry, Jack, but it's basically quite a stable chemical composition, quartz, which makes it good for sort of lasting a long time. So if you just think of a complex crystal lattice, if you like, and the fact that it's quite readily available as well. So when we're looking at sort of making storage solutions cheaper, obviously, if we can use glass, it saves a lot of money because it's one of the cheapest materials on the planet. If we went for something like diamond, imagine how much it would cost customers just to store something like a photo.
Yeah. And also, is diamond much stronger?
Diamond's the strongest material on Earth.
Oh.
Only diamond can cut other diamond. That's an interesting fact for you.
What about titanium?
Titanium's not the strongest, but it's quite strong. It's strong enough, stronger than my skin.
Yeah, it definitely wouldn't be good if we stored it in diamonds because
Don't you think anyone would ever back anything up if they had to pay for diamonds?
Yeah.
Even one sort of wedding ring. Diamond is more than enough for most people and what they can afford. You might find it interesting, but drills, you can get drill bits made of diamond and you need them to go into sort of really other hard materials to drill nails in. So you can get diamond drill bits, diamond all sorts of things. If you need strength, diamond's the best way. In one of my old jobs, I used to work with explosives. So it had like a part of it that was engineering and another part that was all chemistry because you had to look at how the different materials would react with each other. Yeah. And that was very interesting.
What happens if you combine rubidium and water? Does that explode?
Rubidium and water. Do you know the periodic table?
Yeah, I know.
If you look up in the periodic table in your science book, there's a section called the alkaline metals.
Yeah, I've seen that.
At the start. So that's things like lithium, magnesium. And what happens is they react with water, essentially. So the further you sort of go down the table, the bigger the reaction. So have you ever heard of Mythbusters? No? Okay, so it's like a science program that used to be on television. And
it sounds like Ghostbusters, but...
Yeah, Mythbusters. Look it up because on one of the episodes, what they do is they basically put these different metals into water and watch as the reaction gets bigger and bigger and bigger. It starts off as a tiny spark and by the end, one of the metals, it goes into a massive explosive reaction.
Does it actually explode things?
Yeah. It's very reactive, the alkaline metals, extremely reactive, but that's not necessarily what people want.
Luckily, what you did is at least they weren't for bad reasons.
No, that's true.
Because sometimes it can be used in war to hurt people, and that's not good, is it?
They're used for good things as well. Like, for example, if there's a building that we don't use anymore, some of our power stations have been blown up by explosives. You can watch these on YouTube. They're really quite cool. And it's basically the best and the safest way to knock it down that doesn't involve anyone sort of being nearby when it happens. So it's not all bad. Some of it's bad, but not all of it.
I can't wait to get to secondary school to do some cool experiments.
Yeah. You just have to do a mini reaction at home. The one that most kids are allowed to do is the baking soda and vinegar. Have you done that one?
Yeah, I really like a volcano.
Sort of quite safe, but it's a cool reaction. You could do some in a safe way. Just don't go getting any of the alkaline metals and putting them in water.
Yeah, because not go well. So the future of data storage is basically beyond your wildest dreams. thank you so much for talking to me. It's been really interesting and I've learned loads today.
Good. I'm glad you enjoyed it. Thanks for talking to me too. You know, I learned some things from you that I didn't know. So it was enjoyable for me too.
Thank you. Yeah.
See you later.
See you later.
Bye.
Wow, what an interesting episode. And as I said, the possibilities of data storage in the future really are mind-blowing. Turns out the future isn't just thinking about big, it's also thinking about really small, like nano size. We've talked about a few possibilities for data storage in the future, but there are others too, like holographic storage and helium drives. Look them up if you're interested, they're very cool. As Dulcie mentioned, Mum will put links to some videos and interesting articles about data storage in DNA, glass and in the Arctic in the podcast description. Mum will also share the example of encrypted data that Dulcie sent to me, as well as what a cloud architecture looks like. But for now, that's all we've got time for. It's goodbye from me, and remember Frank the dog earlier on? It's goodbye from him too. Join me next time for another exciting episode of Jack to the Future.